The Director General, RCMRD, partners, colleagues, good morning. Good morning again. It's a bit chilly, but we have to be a bit vibrant because we're being given an opportunity to see where we are going in matters Earth observation. And I want to, as we open, I would want to encourage you to take this moment to say hi to the person next to you and know the name, if you can. One of the reasons why we're here is so that we're able to network and create linkages. So if you're able to exchange cards or contacts, that will be most welcome. So like has been indicated, my name is Charles Mwangi at the Kenya Space Agency. At the Kenya Space Agency, we have the mandate of coordinating, promoting and regulating space activities at the country. We are not very old in the market. I believe we have a booth, and we encourage you to visit us at the booth to learn more about the Kenya Space Agency. And for this session, as Mr. Idude has indicated, we have 3 sessions. We will be looking at unmanned aircraft systems for improved decision making. We have a speaker. We have Hawkins Musili, GM Fahari Aviation as a speaker, affiliated to Kenya Airways. Then we have the second session, Earth Observation Services for Resilience Social Systems. The speaker is Lizel Boschov, Commercial Director, Head Aerospace. And then the third session will have Earth Observation Information Processing. And the speaker is Dr. Kohei Yamamoto, the Principal Engineer, PASCO. So the reason why you're having these sessions is to shed more light in terms of what is happening within our space sector, or within the Earth Observation, the application, Earth Observation Application Center, and the different technologies that are there. And as indicated, because we're starting a bit late, we would want to encourage the presenters to try to reduce their presentation to about 20 minutes so that again, we also get some time at the end where we'll have a common maybe reactions from the audience. If in case there is any clarification that the members would want to find out regarding that. So I want to take this opportunity to welcome the first speaker. This first speaker again will be talking about unmanned aircraft system for improved decision making. The speaker is Hawkins Musili. Hawkins is an accomplished engineer and an innovation expert with over 10 years experience in managing projects and teams across various functions within the Kenya Airways group. His vision perspective has earned him opportunities to work on prominent projects such as Fahari Aviation, the emerging technology subsidiary of Kenya Airways PLC KQ, of which he is a founding member. I will invite him and he'll share more. So I want to invite him on stage, and could we welcome him with a clap as we warm up as well?
We're going to focus today on unmanned aircraft systems for improved decision making. And it really goes very well with the theme, $1 trillion of the yearly cost of poor quality data. That is in 2016. So if methods have not been improved and you extrapolate with what you're seeing right now in the economy, yeah, that cost could be very high. However, beyond the dollars and shillings, there's also time. And getting accurate data is both time consuming and relatively expensive. Data quality is a pervasive problem. Poor quality data has the task to determine the correctness of the data coming from Department A, do their own bit, and if that data is inaccurate, you always end up with consequences of any errors that have leaked through. So meaning going back to redo work, that's duplicating the entire organization. Drone technology has demonstrated its potential as a cost-effective and accessible alternative to satellite and manned flight methods of remote sensing. I think that's what has been used for quite a while. And I think the advent of unmanned aircraft systems allows the industry, or gives this industry, a tool, an accessible tool that gives you accurate data. We have examples in agriculture, aerial surveys and mapping that show how the drone technology has helped give very accurate data. Now, as part of our keynote speech from Fahari Aviation, we have 2 more activities. The first, we request our manager responsible for training to take us through one of the projects that shows the use of drones in improved decision making, that is making sure that the data is very accurate. And then, as the moderator said, we'll have a demo at around 12:45. I'll ask our operations manager to take us through that part. And then later on we can take questions and discussion points. Welcome, Hazel.
Thank you very much, Hawkins. We can go to the, yes. So as the presentation is pulling up, I can introduce myself. My name is Hazel Washira, and I am the head of training at Fahari Aviation. So I'm in charge of the training division, as well as support as an instructor. So I teach people how to fly drones. And if you want to know more about our training and other solutions that we have, we assist you at our booth. Okay? So I will talk about one of the projects that we've done to support our industry, that is the aviation industry, just to detail how unmanned systems can be used for improved decision making. Okay. Right. So this presentation is co-authored by my colleagues and myself. These are our partners. We were working in collaboration with one of our biggest stakeholders, that is Boeing Next. They've been supporting us on this project, and the project is, on application of unmanned aircraft systems for aircraft structural inspections. Okay. As I mentioned, this project is a collaboration between Fahari Aviation, Kenya Airways, and Boeing on use of UAVs for aircraft inspections. And the aim of this test is to evaluate the benefits of using UAVs to reduce overall maintenance cost, save time, downtime, especially for our aircrafts. These are very expensive assets that are meant to stay in the air. Improve accuracy, analysis, and recording of aircraft structural defects in comparison to other traditional methods, which include getting a technician up on a step or a scissor lift to go and inspect visually. Okay, so all right, so this is the picture on your left there is one of our 787 aircrafts. Now, imagine you've been told you need to inspect the crown of that aircraft, and you need to do it within a specified time, because when we plan for maintenance, we have a specific schedule, and there's a ground time that has been allocated for that inspection. So imagine you've been told that you need to conduct aerial inspection on that aircraft, and you need to get up there, okay? So this task would require you to have certain tools and certain equipment, some which are not very cheap to find. So we use equipment such as what you see in the middle there, that is a scissor lift to get you up there. And what you see on your right, you can see a giraffe, yeah? And many other steps to be able to get you up there. So sometimes it takes a while to go get this equipment and get a technician or an engineer up there. So it takes a while by the time you get all your logistics and everything set up. So we are trying to see, is there a way that we can use aircraft, drones, to be able to assist us to do aircraft inspections, okay? So this is a sample of a damage that was on our 787. As you look at that damage, many of you may not be able to see it, right? But that specific damage is a damage that requires the aircraft to be grounded. Now, this damage is on the aircraft door, and in normal occasions when the aircraft is parked at the airport, it's not very usual to find ground equipment to assist you to go up there and do inspections. So it becomes a challenge, especially in the airport field. So the objectives of this project were, one, to compare the general visual inspection to drone flight inspection, assess time efficiencies, and assess accuracy and effectiveness of using drone technology. So we set up a team together with Boeing, and we sat down and we said we want to apply drones to inspect our aircrafts. Okay, so we went into a training session, as you can see there, where we learned now how to map the aircraft to be able to inspect using drones. Then the second part entailed marking the aircraft. So as you can see, the aircraft, as you normally see it flying, it's not normally marked. But when you use a drone, you have to mark it so that you know the position where you're flying. So we had to map the whole aircraft fuselage so that as we are flying, we know it when we take a picture where that picture is. Okay, so that we are able to relate it once we get the images from the drone. So we had to make the aircraft to identify the UAS flight path, as you can see from the picture on your right. And then we conducted the test flight, flying the UAS as close as possible to the aircraft body. Now the aircraft that we picked was a very special aircraft. It's a very stable aircraft that enabled us to also fly within the hangar. And then the last step was now engaging in the test flight inspection. So we carried inspection of the fuselage of the aircraft. We did three main parts. We did inspection of the vertical stabilizer, the horizontal stabilizer, and the fuselage. Okay. Now, the idea was to compare between what a mechanic would see and what an independent mechanic would see if they're given images from a drone or from a UAV. Okay. And after comparing the results between a mechanic versus a UAV, we did an analysis for each particular area. So for the vertical stabilizer, we had a 44% correlation, meaning 4 out of 5 were not captured by the mechanic. So we figured that this might be as a result of height. On the horizontal stabilizer, we had a 71% correlation, meaning 2 were not captured by the mechanic. On the fuselage, we had a 29% correlation, meaning 4 out of 5 were not identified by the mechanic. And on the wing, this was not accomplished because the drone camera angle was not able to get the perspective. Means it cannot be able to get images up, okay, because of the orientation of the gimbal. The conclusions from this project. Now, we concluded that UAS images provide more detail and accuracy to the structural defects. As you can see from the data, the correlation, we had incidents, we had images where the mechanic was not able to identify the defects that the UAV was able to identify. And image capture can be stored for future reference, which is a very, very important tool, especially when you're dealing with data. Now, the opportunities from this project, one, as I mentioned with the wing, we had a challenge because we're not able to orient the gimbal and take images. So one, improved gimbal orientation to cover the lower body sections. We're also looking at automated flights. This would remove the need of marking the aircraft because it's a very time-consuming event where we have to physically go to the aircraft and mark all the stations of the aircraft. So if we are able to have automated flights, integrate the body stations for the aircraft into the design, then that would help in terms of flight planning. Then exploration of other sensors such as thermal, especially when you're dealing with aircraft damage, structural inspections. Okay, so these are our collaborators and stakeholders. This project was undertaken last year. We are progressing the project. We did a second project this year, and we're continuing to work with Boeing to be able to validate the use of aircraft systems for aircraft inspection. All right, I will invite my colleague Naima to take us through some of the solutions that we offer at Fahari Aviation that also will touch on the improved decision-making importance.
We might not be able to, unless if it's done quickly because we are running out of time.
Yes, she'll just take 5 minutes and just talk about especially the drone demo. I'm sure you're all excited to hear about that.
Good morning, everyone. My name is Naima Sheikhan. I lead the operations team within Fahari Aviation and also a founding member of the initiation of the project within Kenya Airways. I have a background in drone technology, particularly aerospace. Started as an engineer at Kenya Airways and now transitioned to develop emerging technologies within Fahari Aviation. So to move forward from what my colleagues have talked about, especially from a Fahari Aviation perspective, as we aim to develop sustainable solutions within the emerging technologies, and our key focus right now has been in drone technology, as that is the emerging technology in Kenya at the moment since we got our regulations in April 2020. So to start off, to look at the key areas that we service, from the agriculture, the mapping, monitoring and surveillance, inspections, conservation, photography. So when you look at the solutions that drones provide, you'll find that they're very versatile and the solutions are vast. So we can mention them and they can be more than 12 or even to 24 or 30. But the key ones that we feel that will develop much faster, rapidly, and also improve socioeconomic effects in Kenya would be on the agricultural perspective and also in the aerial mapping and surveying. Moving on to other solutions, the services we currently offer. We have, from a training perspective, if you visit our booth today, you will see that we offer different courses in training, from your initiation of your pilot license, and also if you want to convert your license, if you have a drone license from a different state, and even to enhance your skills when it comes to flying a drone. And on the data processing and management perspective, this is where we look at the solutions that we provide or the applications we provide. The drone is just a tool to provide images, to carry a payload, to do various aspects of what you want to do. And what you consider the payload is what you carry on the drone. So it is just a tool for you to have a solution to it. Is it data processing that you need to do? Is it data that you need to retrieve? So what we consider ourselves is providing an end-to-end solution, from the time you fly the drone to the time you deliver the data that is required to enhance efficiency. On the consultancy perspective, it's based on the regulations, the Kenyan regulations. There's many standards that have been placed which are adapted from the technology, the aviation technology, especially manned aviation. So we as the experts in the manned side, we understand the regulations, the Kenyan regulations placed, and we can support you to develop your own training organization or operating organization as per the regulations within Kenya. On the distributorship and supply aspect, we know that there are individuals who would want to utilize their own drones. And if you want to purchase your own drone, especially with the largest market in DJI products, you can reach out to us as well, and we can offer you the importation process and also registering your own drone and also bringing it into the country. So, as I mentioned, just come to our booth after the breaks, and you can learn more about what Fahari Aviation does. So, not to waste more time, I'll talk about more of what we're going to be doing today, which is the demonstration. If you look at the slide that I have there, it's more of projects that we've conducted from an agricultural perspective, which is on your left. Then you have our KWS on conservation, the aircraft inspection. We have Olpejeta, where we've done also conservation in terms of counting the animals. Power generation at Olkaria, just doing a structural inspection. We have seeding at Kaptagat, and also, as you see, our former president trying to fly a drone, just like the ones you fly at weddings. And the biggest news that has been out there for Fahari Aviation, which is introducing of flying taxis, which we call eVTOLs, electric vertical and takeoff and landing equipment. So this is in development, and we look to enhance the technology by 2024 to bring it to Kenya. So our demo for today, at 12:30, as has been mentioned, we'll be showcasing 2 of our key applications, as I mentioned, which is part of the theme of this conference, from agricultural perspective and also from the mapping and surveying perspective. So from the agricultural side, we will deploy a 30-liter drone, which actually is 30 liters if you're carrying a liquid, and 30 kilos if you're carrying, let's say, pebbles of fertilizer or seeds. So with this drone, we actually fly almost an acre in 5 minutes, and we actually complete spraying across a certain area. You find that it is very quick and efficient for the people who apply drone technology in agricultural perspective. So if you go back to the end-to-end solution, you find that with these type of drones and the way you can utilize them when the GPS coordinates, you can actually focus directly towards where you want to apply your fertilizer or you actually want to seed, and actually do it more efficiently than spreading it across a certain area. And on the second one, we'll have our mapping drone. This is a fixed wing vertical and takeoff landing drone. Usually we utilize multi-rotors for short areas of surveying, but if you want a large scape of surveying and you want to take images over acres and acres of land, we have our mapping drone that we'll be showcasing today that does over 50 kilometers of communication range and can do almost 2.5 hours of endurance. So if you're even mapping a forest, this would be the best tool to do it. Almost 42 megapixel camera as well. Yes. All right. So I look forward to seeing you all there. It will just be behind this tent, and we won't take much of your time. And we'll look forward to seeing you there, and we'll discuss more about what the drone is doing while we're there. Thank you.
Thank you, Fahari. I apologize. We had to rush them, and we know it's exciting to hear more about drones. And again, that's the next frontier, and I see a lot of young people here. Those are opportunities that you need to have discussions and see how you could use that technology. And one important point that I would take home is the one that was shared on the importance of data and the opportunities that it presents. The whole value chain on data is quite elaborate. So again, a round of applause to that team, and visit them at the booth as when we have that session. The second session we're going to have is on Earth observation services for resilience social system. And we have Liesl Boschel. I hope I am not butchering the name too much. She's the commercial director, Head Aerospace. I want to invite her, and then she'll share more about what they're doing at Head Aerospace. Karibu. A round of applause as we welcome her.
Good morning, everybody. Nice to see so many faces on a rainy day. looks like Cape Town weather today. Right, I am Lizelle Boshoff. I represent Head Aerospace in Paris, and I am based in South Africa, in Cape Town. Our head office is in Beijing, where we have 1,000 employees. And Head, I always like to say, sees itself as the bridge between Chinese satellite operators and the Western world. There are so many operators, and I always say they are producing satellites, mass producing satellites in China at the moment, and launching every week. So let me tell you, like my previous speaker said, we cannot afford to have bad data anymore. So let me tell you what Head is doing to give you very high quality data faster than ever before. So, right. Okay. I'm quickly gonna run through these satellites that we have at the moment. 86 satellites in orbit, ready for commercial use. 2 of which is 30 centimeter resolution satellites that just recently been launched. And we have another 5 50 centimeter satellites. And I would like to tell you also more about our daily vision satellite constellations, where we have 41 satellites monitoring your sites anywhere in the world. Optical microspectral satellites, we have Nature Eye, we have stereo satellites, we have hyperspectral satellites, and then C-band SAR satellites, X-band and L-band SAR satellites were recently launched. Our night vision satellites, taking images at night, videos at night, those have also been launched. So whatever your application is, we have the satellite for you to task your areas. So in the last couple of months, we've really launched 30 satellites successfully. And our aim is in 2025 to have 200 satellites. As a competitive advantage, Head has obviously optical radar, hyperspectral video, night image satellites. We also have more 30 and 50 centimeter satellites in orbit than our competitors, as well as sub-meter optical. We have 67 satellites for monitoring as opposed to Planet's 21. And then of course we've got the SAR satellites. So I want to go a little bit more into detail just on the satellites to give you an idea. The 30 centimeter satellites that's just been launched have your spectral range, pan, blue, green, red, and near infrared. And quality like we haven't seen before in 30 centimeters. Right. Our SuperView satellites is 50 centimeter resolution. We have 4 in the constellation. Daily monitoring by the 4 in the constellation. An average of 2 million square kilometers per day gets tasked. So you can imagine we have got a very big archive globally available. And I think for 2022, most areas have been 80% collected. I need to also tell you about our direct receiving ground stations that we supply, and I'm happy to see our colleagues from ST in Ethiopia also here this week. We have recently, in the last couple of years, supplied Ethiopia Space Agency with a ground station, including antenna system, data processing system, data application software, and I'm happy to say, due to the hard work of that team, it looks like it's fully operational, and they are downloading data and imagery at the ground station and distributing it to the ministries, which is where I think all of our space agencies in Africa wants to be and wants to go. So reach out if you want to talk to us more about that, and also about acquiring your own satellites. The SuperView constellation of 4 has got a vast and very big archive, as I said, and I also want to mention the X-band. 2 satellites were launched, dual formation, bringing you INSAR imagery, and for the Netherlands Space Office, they have a data portal, and we supply and task the whole of the Netherlands every month for them with SuperView, and the data is available on their portal. Excellent data that they use for, you can see, site preparation of a new roundabout, and then when it's done. The Earth scanner I would like to tell you about, that is a very big satellite, as you can see at the bottom of the screen. It is 1,200 kilograms, and it has a swath of 136 kilometers, and we have 3 of those. The latest one was launched a couple of months ago. It has a swath of 150 kilometers, and this satellite we use for country coverages, for instance in South America, or very big countries where you use 3 Earth scanners, and in a couple of weeks you can have the whole country collected with 50 centimeter satellite imagery. With that kind of swath, we've recently captured 2 countries in one pass with the Earth scanner. That was Bahrain and Qatar. 50 centimeter satellite imagery. It's a beautiful product. I've taken the liberty to have a look at Kenya. We have 92% coverage of Kenya with the Earth scanner with 50 centimeter already for the last 2 years. And if you can see the strips, it will take about 7 strips to cover Kenya. So very possible for us to give you a country coverage 3 times a year, like what we're doing for South Africa now. Happy to say that our global 75 centimeter mosaic is coming online and should be ready for web services towards the end of the year. Beautiful data, the global base map 2021. There's Nairobi, and it's very good quality. Also need to tell you about our automatic building footprint extraction from the Earth scanner from 50 centimeter satellite imagery. Also a very nice product. Recently done it for the whole country of Lesotho. So high revisit times. Every 15 minutes we can monitor your target, your site. So I remember beginning of the year we could only monitor in the mornings from 9 o'clock till 12 o'clock every 15 minutes. But now, since last month, we've launched another 10 daily vision satellites for the constellation, which is at 63 satellites at the moment. When we finish, it will be at 138 satellites in 2025. So at the moment now, we can monitor your site every 15 minutes from 9 a.m. in the morning until 5 p.m. in the afternoon. We've done a border collection for Brazil, Paraguay a few months ago, and with this constellation, and every 15 minutes we tasked and monitored the area. Like you can see there, this is with 1 meter satellite imagery. 9:28 we tasked the first one, and then 9:43, and then again at 9:59, 10:23, 14:34, and then 21:52 nighttime, and then a little bit later you can see there's less lights at 22:22 we also task. So bringing me to the night vision imagery, we can supply you the images or the video, 30 seconds video at night. For instance, Cape Town Port, we are busy helping them for disaster management and all kinds of monitoring that they need to do by video at night. I think it is the departments of science and technologies in Africa that's very interested in this kind of data, as they want to attract investors for power projects into Africa. They use night vision to show how dark the villages in Africa is, and we need more power in Africa. So they use night vision to show that. Right, and there's a day vision, a day image with your night image combined. C-band radar constellation we have since 2016. Radar, as you know, collecting through all sorts of weather conditions and also at night. This is a night image showing multiple shipping vessels leaving the port. I'm very happy to introduce our new SAR L-band imagery. This satellite was launched last month, and as you know, they can penetrate through trees, through the trees canopy and water, and this is very good with helping to build your DTM as well. This is your before and after calibration of the L-band. We have a stereo capacity stereo satellite called ZY3. ZY3 is capable of collecting panchromatic stereoscopic pairs covering the Earth seamlessly. For 1 in 50,000 mapping, the stereo with GCPs gives you a positional accuracy of 10 meters, and with GCPs 2 meter elevation precision. A composite using stereo imagery with laser altimeter data, giving you a vertical accuracy of 5 meter without GCP. Our Gaofen 7 satellite, the elevation precision increased from 5 meters to 1.5 meters. Stereo imaging with laser altimeter, vertical accuracy 1.2 meters without GCPs. Hyperspectral satellite with 166 bands. and Gaofen 5, which is a hyperspectral satellite that's got 330 bands. We've got our 5-meter Hyperscan satellite. And then HED has a Skywalker constellation system for space IoT services. We use an innovative approach, leveraging IoT and Earth observation combination, where we equip the ships with HED terminals and providing tipping and queuing with VHR, fleet management and maritime. Thank you. That's it.
Thank you, Lisa. Let's give her another round of applause. So we've gotten data from space. We've gotten data from near space, if I can call the drones operating near space. So we're saying data is available, or it's close to being available. And then the challenge to the geospatial community is, are we able to get insights from that data? Are we able to make decisions using that data? Because we're saying now it's available. How then do we convert that into decisions? So we move on to then the last but not least presentation, the keynote address number 3, where we'll be looking at Earth observation information processing. We have a presenter or the speaker is Dr. Kohei Yamamoto from PASCO Corporation, and I want to invite you to make your presentation. Let's welcome him with another round of applause.
Dear Chairman, Director General, and distinguished guests, and ladies and gentlemen, good morning. Yes, today I just would like to share with you the EO satellite techniques. But as yesterday I mentioned, PASCO is a company to manufacture of wear. So we are capable of how to use the geospatial data. So I'd like to share with you today how to make it useful with the satellite data. But however, why PASCO came here is to introduce you the JAXA, Japanese Spatial Aeronautical Agency, Space Agency's new satellite L3. So let's move on. So firstly, I'd like to introduce PASCO and myself a little bit. And I'm working PASCO 33 years, that is tremendously long. And my first career started as a GIS engineer. So almost quarter century ago, I stayed in California, Esri. I stayed at Esri 1.5 years. And after then, I switched to the more overseas aid project guy, and I do a JICA project. And 5 years ago, almost from 2016 to 2017, I worked for the KFS project, Karura Forest. I love there. And so get back to it, slide. So PASCO is a company of the surveying company. And the net sales size is almost 55 million US dollar size. Okay, I translated it. And we put the stock share Tokyo stock market first. And we have 2,700 employees around the world, but almost shrink to the South Asian part, but used to be a worldwide operation we did. And PASCO's three key factors or priorities is remote sensing and on-site sensing. What on-site sensing means is like a conventional surveying style. Yes, I usually doing the survey. Yeah, I'm a certificated surveyor in Japan, actually. So we do surveying. And analysis technology is like a AI and image analysis and IoT and GIS. So we do mix with these three technologies into the solving social issues like a natural land conservation and disaster management and infrastructure management and so on. And I'd like to precisely explain to the satellite, our remote sensing sensors from satellite to the sea bottom vessels. So we do a lot of aerial survey actually, and however, recent 2 decades we proceeded to the more satellite business area. So we do satellite data processing well. And PASCO use satellite business. I would like to explain to you. Yes, we started satellite business from a German X-band satellite, TerraSat X, and we do JAXA satellite business since 2011, and that was the era of the very huge earthquake, East Japan earthquake damaged. But we are lucky, we archived just before earthquake image with this EROS, first generation of EROS, so that we are able to present to the government what is the flood area, what is the tsunami damaged area. Within the 3 days, we submit our analysis to the government. So government recognized the powerfulness of the satellite data analysis work. So now Japanese government put the money, put the budget for the more of the satellite. And so next generation L2 is L-band SAR, like Lisa-san explained that L-band is very suitable for the to acquire the terrain model of the surface of the globe. So that it compared to, I will explain to you later on. And other satellite image we distribute again. So what is the characteristic feature of the PASCO satellite business is we can do from the top of the bottom. Like we acquire the satellite image and we receive the image, we process it, but because we are the geospatial company, we process and analyze and to serve to our customers with the analysis part. So this is a characteristic of PASCO's businesses. And so PASCO's business leads to the every SDGs aspect, like it's just the prevention and land management and infrastructure. And environmental conservation, and like economical GIS analysis, like logistics services and market planning, and like the other overseas aid project, like at the KFS, we do the we're using with the Landsat data and spot data, so we analyze the difference of the past and present with the forest conditions, and to create a database of that. And let's move to the ALOS of the JAXA satellite business. So as I mentioned, like ALOS first generation is very popular for the African countries because there are a lot of users of ALOS. 2.5 meter ground resolution that was, but already terminated. And now currently working satellite is a SAR satellite, L-band SAR satellite. So we have a lot of orders for the SAR observation for that. But I put the right letter of the 2022, so that is the current situation. So Eros-3, new optical satellite will come up 6 months later on. And Eros-4 will be with success of the Eros-2 in the next year, and that will be the 2024. And so PASCO contracted with JAXA as a prime distributor of the Eros-2 and Eros-3. So we are providing these kind of data all around the world. So this illustration explains to you what is the difference of the optical satellite and SAR satellite. Hey, look at that picture, please. So optical satellite cannot detect under the cloud. So interferes with cloud is a very, very problem for that. However, on the other hand, radar image acquisition, that is a SAR satellite, can penetrate through the tree top to the ground because of the wavelengths can penetrate through the tree cover of that. So, because radar image is not the optical image, not visible image, that is invisible. However, it can be synthesized with black and white images. So you can sense in the nighttime or very cloudy or this weather, it can be sensed with the terrain conditions. So this is basics of the optical and radar satellite. And Eros-2 is now currently working satellite. So the best resolution is 1 meter by 3 meters. However, normally it was we have accept the orders up to the from the ultrafine to the scan cell width, and launched 2014, and revision time is 14 days. So I'd like to move to the mission Eros-2 incomplete. So this mission is a disaster mostly. However, there are various partners around the world of the Eros-2 users. So I'd like to introduce. So this is a Chinese land deformation prediction project. So our partner in Beijing are doing with Eros-2 satellite with monitoring purpose. There are 100 AOI, area of interest, to be monitored with the disaster. So Chinese company doing a lot of businesses with this Eros-2 landslide monitoring. And next, this is a 3D geomatics study Canadian companies. What is they use take advantage of the Eros-2 L-band. They are what they want to do is to monitor the pipeline, but tree covered. So tree covered, under the tree cover, they would like to monitor the pipeline position and deformation. So they use mostly this Eros-2 L-band SAR, and they do a lot of project with this pipeline analysis. And next is Astera. Astera is an American company, but related with Israel company. And they find the water leak with the SAR satellite. Because SAR satellite can detect with water condition on the surface ground. Sometimes there are some of the applications of like locusts. 3 years ago, 2 years ago, there are a problem phenomenon on the locusts, but the locusts put into the ground their eggs to the ground. So their wet ground is some of the potential of the local problem. But in the India, there are very dry land, so locusts has been stopped at the India at that time. So this kind of algorithm, they use detection of the wet condition, and they find a water leak of the water pipelines. So they use the infrastructure management with this SAR satellite. And let's move to Eros-3. So L3 would be newly launched with the specification. I'd like to ask video to explain. Would you click the video? Touch the video? Again. No. Click video. No. I'm sorry. Yeah, no, this one, not this one. So I'm sorry. Yeah, please stop by our booth because we have the video explanation that characteristics regarding to the L3. Yes, I skipped L3. So what is the characteristic of new satellite L3 is a very wide swath. So suppose that this 20 kilometer by 20 kilometer is a very high resolution satellite footprint, and 10 kilometer by 10 kilometer footprint is like a constellation small satellite, 100 kilogram size. But L3 can cover 70 kilometer by 70 kilometer footprint. That is enough to cover the boundary of to cover the municipality or the local government purposes. So this very wide swath can realize that a very good weather condition to acquire the whole nation cover with a very good satellite imagery. And so resolution has been improved from the first generation of ALOS. So from the right-hand side, GSD 30 meter is like Landsat size, and GSD 10 meter is a Sentinel free satellite size. But GSD 2.5 meter is first generation of the ALOS, but would be improved to the 80 centimeters. So yeah, it is hard to distinguish that, but you can distinguish that power line can be distinguished with the 80 centimeter resolution. And new satellite put with the coastal band and red edge band. And red edge band is suitable for to find out the health monitoring of the plant leaves conditions. And coastal band can penetrate through under the sea level, so it can be detect the cliff, dangerous cliff area more than the RGB. And what is the point of the L3 is a very high quality data, because this is a very large size satellite. So the attitude control is attitude and positioning control is very, very severe. So it can create a very good horizontal accuracy of the image data. And that is good to analyze the AI technology. With the AI technology, later on I would like to introduce you. So PASCO has a contract. Yeah, JAXA, Japanese Space Agency, owns the satellite, but we developed the ground system, and we process it, and we operate it, and we distribute it. This is a contract of PASCO. And please come to our website. And other things is what we do is not only the distributing the satellite data, but also that we use it with brand new most modern technologies with the AI. So there are a lot of satellite resources, not only the optical but also satellite. So we use this Earth observation satellite data. Not like a weather satellite, GNSS satellite. Like Earth observation satellite is below than the 1,000 kilometers away from the ground, but the other GNSS or other is 10,000 kilometers away from the ground. So very close. So EO satellite, optical satellite is like close to the visible ranges, visible wavelength ranges. but radar satellite is not visible range. However, it can be sensed with the ground, penetrate through the ground. So advantage of satellite data, like Hawkinson mentioned that, yes, precisely we need to survey with UAV tools, sting out with the UAV tools. But wide image and no flight restriction is the characteristic of satellite data acquisition. So with a monitor with screening out with satellite imagery and analysis, and we do the survey with UAV or another conventional survey way on the site. This is basics. And when it comes to AI, there are a lot of argument with what is AI. So I'd like to define the terminology, like yes, deep learning is, we call it mostly AI, and the models is a kind of the program of the result of the AI analysis, okay? And what we promote the AI things is that since 2006, we started the satellite business, and recent decades, we develop our AI skills more and more. And finally, we come to awarded, but already, or 4 years ago, we have awarded that classification accuracy of the building footprint. And we, at the Deep Globe CVRP 18, we have been awarded first prize. What is the tips of the building distinguish is to classify with a low story, with a middle story, and high story. So it can be calculated out with an estimate with the footprint. And we put the sum of the optical satellite imagery with the shadow lengths of the high story buildings. And on the other hand, like a road detection, yeah, we can do with road detection. So right-hand side is a ground truth image, but left-hand side, that is the middle bottom, is a result of the AI. So that is not so different from that. This road is like a Indonesian Jakarta image. There are a lot of crowd area. However, almost 90% road are acquired. Yeah, this is a detail of that. So there, we can distinguish whether a change of the road development. I'm sorry. So I just would like to introduce you the actual project in Japan. So property taxation is most concern of the local government revenues in Japan. So we offer to the Yokohama city. Yokohama is next to Tokyo, very large size population, and they apply our AI building detection with that. So this is a newly constructed building or demolished building. This is a problem for the tax matters for that. So we provide and submit with the AI result to the Yokohama city, and they do the correctly, so they reduce the error of the wrong taxation. Yes, they are really satisfied with this result. And next is a population estimation. This is not a public service like a commercial usage of the, like a Japanese commercial like retail stores, like a 7-Eleven or Family Mart, yeah, very small retailers would like to proceed to the Jakarta cities, and but they need a very good statistics data. However, statistics data in Indonesia is quite old and the cycle is quite long. So we offered that company to sharpen up the statistics result with a satellite AI analysis result. And we create, we distinguish the stories of the buildings with low, middle, high, and put some of the attribute of the like estimated resident number of that, and summarize with it, and it would be the mostly 80%. However, 80%. Precision. However, it can be useful for the commercial analysis usage. And next is the path field detection with the satellite imagery. So if we put the training data, right, like existing GIS data of the parcels of the path fields, and it can be learned as a training data for the AI modelings. And after learning of the modelings, and we adapt to the another place to extract the path field area. So yeah, it is really, I mean, worry about if you stand on the in the dead middle of the path field, you lost at the way because on that. Yeah, I do the like a GCP ground control point mark on the path field, and we easy to at the loss of the where position is. So what I want to try to explain is this kind of extraction of the polygon is should be automatically did. 20 years ago, we manually did with the cost of the manpower, but it should be this kind of AI technology area. So this is another one. So that if we combine with this vector data with raster data, which analyze with directly with the satellite data, or the, like Liz mentioned, the daily or 15 minutes monitoring, maybe we can apply with such kind of constellation data with these kind of automatically extracted polygons. Okay. So, like I mentioned, yeah, we do a lot of GIS and remote sensing businesses around the world, but it leads to the SDGs every aspect. So summarize. So Pasco doing the SDGs with their GIS and remote sensing and AI technologies, and the Japanese new VHR, a very high resolution timing L3 will be launched soon, and satellite and AI solutions are viable. Thank you very much.
Thank you, Dr. Yamamoto. Let's give him another round of applause. I know we are running a bit over time, and we would want to move to the other sessions, but we wanted to get some feedback from the participants who are here. We'll only allow for 3 questions, 1 question from this side, 1 question from this side, and 1 question from the other end. And I'll request the team that is moving up the microphones to assist that. So any question to any of the presenters from this direction, if your hand comes up first, I will pick you, and then we'll move on. This section, there is no question, so we move to this section. Or were you not told there will be a question session? I see a question on the back there, so. There's a gentleman back there, if you can get a microphone. Maybe you could be standing so that they see where you are at. So I want to request that you also keep the questions brief, because we are running a bit over time. Thank you.
Thank you very much for the presentation. I would like to ask whether we have provision for those kind of data sets that we have been seeing from the presentations. For research purposes or for student package that we can make use of them in our kind of projects that we have in different fields.
Thank you. We'll take the next question, and then finally we can have another question on the other end, and then they will respond as they make their final comment.
Morning, everyone. I come from the water industry. I've seen so much good information on satellite images. Now, we normally have a great challenge of non-revenue water. I've seen improvement to satellite, they can capture data maybe after 10 to 15 years. So, the only challenge that water companies face in Kenya, it's no budget, there's no money out. So my question is, what are the cost implications of these images in terms of budget, cost, how much does it cost?
Thank you. The question in terms of the cost element. If we could have one question from any participant, there's a lady there. Maybe you could give your name and the question.
Hi, my name is Rose. I just have a quick question for Fahari Aviation. I've realized you said that you have to mark the aircraft to be able to take pictures. Is there a solution for not having to mark the aircraft? Because I presume it takes time and a lot of manpower, which you're trying to avoid by taking the pictures. So what is the solution for geolocating, like where the picture is taken without having to mark the aircraft?
Yeah, I think it's more also related to the ground control points that you use when you're mapping. So I'll give a minute or two to the presenters to maybe you can stand and maybe face so that we, on the interest of time. Thank you. Okay.
Thank you. Thank you for your attention. I think we'll keep engaging more. There's a booth there where you can get more information. So I'll start with a question on, I know you're mostly asking towards satellite images, but you could still get water resources using drones. I know there's a challenge from a coverage perspective. The way the technology is improving and advancing, at Fahari Aviation and other similar organizations, you do have access to high clearance drones. So you get images of large areas, and it could talk towards maybe reducing the high cost of satellite images. But to the point, the question for Fahari, exactly in terms of mapping the aircraft to make sure you're able to get the exact location of what you're taking or what you're expecting. So what is currently in development, and I think my colleague Hazel alluded to the same, is that we are developing with the help of Boeing, and of course it's going through FAA approval, that's Federal Aviation Administration, is we are developing software particular to each kind of aircraft, which will allow the drone to have automatic flight plans around various construction areas of the aircraft. So if you're expecting your fuselage, you have a flight plan for the fuselage. The same would happen to a Boeing. Our work is mostly with Boeing because that's the aircraft we fly, but I know the other industry players such as Airbus putting effort in that regard as well. So that will eliminate what you've pointed out, which was a point of improvement for our project, because we did spend a lot of time marking the aircraft, grading it up so that we have exact location of damage. Thank you.
Thank you. Maybe we go to Dr. Yamamoto, and then we have one final comment from this end.
Yes, thank you very much. I'd like to answer to the first question that for the training and learning purposes, this kind of geospatial data should be like used for the learning through the e-learnings. So nowadays, the cloud technologies would be adopted these kind of conditions. So what is interference of the data data business is the copyright. Copyright is the downloading and printing out. However, on the cloud, there are no use of the to download or print out in order to have the training how to analyze the data, how to analyze the issues, social issues. So yeah, in this case, Japanese government now preparing for the Japanese version of the e-learning cloud with the Japanese AL3. But later on, it comes up to the couple of years later, English version would come up, and maybe another JAXA and JICA would cooperate together to provide a specific project for the learners of these kind of satellite image data. Is that the answer? Thank you very much.
Thank you. We can have Lisa. Yeah.
Thanks. The question about for students and universities, yes, it's very important for us at TED to invest back into our universities and students across Africa. And we have a division that will assist. So I think best is for you just to send us an email and we'll take it from there. But we do provide our students with data. The other question was for the data, the monitoring, the cost?
Yeah.
Yes. So, yeah, look, I think the cost is coming down, especially nowadays with all the satellites we have and all the archive we have. So for monitoring purposes, depending really, do you need it monitoring every month, 2 months, weekly, 15 minutes? It depends. Obviously, the more frequent, the higher the cost will be. But again, I think best is to send me your AOI. Let the team work out the best way to monitor that site for you within your budget.
Thank you. Just to conclude, I would say the key highlights from that discussion, and that was mentioned by Lisa and also Hawkins and alluded to Yamamoto, is we cannot afford to have bad data. And from their presentations, we've been able to see that there is data available. And I just want to share a bit of insights around the data ecosystem. So currently, when you're looking at the value chain for Earth observation, we have data as a service, we have platform as a service, we have analytics as a service, we have insights as a service, and application as a service. So when you look at the data, much of the presentation has focused on the data, the availability of that data, whether it is from the drone or from the satellites. And then we get into the space where we look at the platform, and I can see Dr. Mubea here. There is the Digital Earth Africa platform. There is the Google Earth Engine, and again, that could also address some of the questions that was mentioned. Google Earth Engine platform, the Amazon Web Services, Esri platform as well. But again, now the challenge also now goes especially to the younger people and the people who want to set up business. And some of the examples were shown here in terms of how then do you analyze that data to provide useful information. And that's why we're looking at analytics as a service. You being able to provide that insight from that data. And then there is the insight again, which is essentially the actionable information that you'll be able to make, or using that data to make decisions. There was a question about water. Are you able to develop a solution that him as a stakeholder within the water industry, you are able to address? And I believe part of the reason why we're having even the presentations here is to help you understand what are the areas that you'll be able to address as a person, as a company, or as an institution. And again, of course, there is also the element I mentioned, application, essentially software as a system, where you could say, if just for the example for water, are you able to provide a solution end to end that maybe queries data from HEAD, if there is that platform, or from ALOS. ALOS has been mentioned. And again, also one of the steps that we're also working on as an agency is to try to create that ecosystem, that data ecosystem where you would be able to make data more discoverable, especially from different governments. And again, another important element was mentioned by Dr. Yamamoto on the use of AI. And again, there is no reason why, again, I know our systems, we kind of focus on one particular discipline. We are encouraging the people in the geospatial industry to move towards the AI because, again, that makes processes much more effective. So that, again, as we move to provide solutions, we are also able to advance in terms of technology and have spin-ins and spin-outs within the ecosystem. I again want to thank the very able presentations by the team from led by Hawkins from Fahari. The team, again, it's a one-lady team from Head Aerospace and Dr. Yamamoto and the team from PASCO. We want to encourage you to visit them at the booths, those who have the booths, and then you will get more insights. We had to rush the program again because we started a bit late. Let's give them another round of applause, please. And let us give yourself a clap because you've been a wonderful audience. So we're going to move on to the next stage. I believe it's a health break, and then we will convene later for the other session. I think
data sharing, where you can access different forestry sectoral data and share it amongst interested partners. So OFESA is working towards covering this gap in these countries, and also we are looking into fostering data sharing policies, in-country policies, and a policy framework that is going to be regional. So another thing that OFESA is going to look into as well is the State of Forest report, where all these different countries will have an opportunity to state where their forests are currently, and we are hoping that this will be able to foster and open up that portal for data sharing in the East and Southern region. Thank you.
Thank you, Ivy. I'll now invite Michael Kimani Ngugi. Kimani Ngugi will be talking on behalf of BioPharma. And it's a project which also funded by European Union and sponsoring part of this session. Welcome.
Thank you, Sweta. My name is Michael Ngugi Kimani. I work here at Regional Center for Mapping of Resources for Development. Yeah, one of the other partners that is sponsoring this particular session is BioPharma. BioPharma in full means Biodiversity and Protected Area Management. It deals with the management of protected areas. So protected areas like, for example, national parks, wildlife, forest reserves. There is a booth for BioPharma. If you want to know more about it, you can visit it. I would also say the BioPharma project here at RCMRD is in charge of managing and updating the Protected Planet. The Protected Planet is a comprehensive database of the world database on protected areas. So if you're looking for protected areas data for any part of the world, you can access it under the BioPharma Regional Resource Hub. And at RCMRD, we update the database for the 24 countries we cover, from Sudan all the way down to South Africa. Thank you very much, and I hope you have a good session.
Thank you, sponsors. Now we are going to move to the presentations. We shall have 8 minutes of presentation and 5 minutes of questions. We shall take reactions after all the presentations, so kindly just note your questions that you might have, so that we allow the presenters ample time to make their presentations, and therefore we can interact with them. So we'll go with the first presenter, who is Hussein. Hussein Farah will be presenting on Earth observation-based protected natural parks, monitoring and management. So if you are ready, then please welcome. Keep time, 8 minutes.
Good afternoon, ladies and gentlemen. I will be presenting on behalf of Dr. Farah Hussein. And my name is Robert Kimtai. I work for DRSRS, that is Directorate of Resource Service and Remote Sensing. And I'm also part of the technical team that worked on this project. You can display the title of the project. I was part of this technical team that worked on Earth observation, based protected national parks, monitoring and assessment in East Africa. And next. Let me take this opportunity to acknowledge the following authors. I'll start with Hussein Farah, who is a CEO for Front Surveyors. I'll also acknowledge Eugene Kamale, Viola Otieno, and Kenneth Mwangi, all from ICPAC. It is also worth mentioning that this project would not have been successful without support from this organization. I'll start with GMES and Africa, Africa Union, ICPAC, Frontier Surveyors, Uganda Wildlife Authority, UWA, Kenya Wildlife Service, and to some extension DRSRS. In case of any queries, clarification, remarks, you can contact me on that email, kimtax@gmail.com. These are my presentation outline. I'll start by introducing the project. I'll also talk of the main objectives that we have in the study. I'll also talk about the methodology that was used. This is very critical. Results also, the preliminary results that we got from this study. User manual development, it's also very important in this study. I'll also mention about it. Expected application, we need to see the application of our products. And also I'll talk about the stakeholders and who are the users of these products. Land use land cover mapping provide information on a wide variety of natural resource management. And also it provides a vital basis for the formulation of policies such as landscape restoration, forest tracking about deforestation, and also it provides information about greenhouse gases emission, because with this data we went up to 1990. With Landsat you can go up to 1973, but with the interest of this project we went up to 1990, up to 2019. And also for the interest of climate change, it was very important because, and especially with the UNFCCC reporting. This study focused on the three countries, which includes Kenya, Uganda, and Tanzania. And we gave chance to these respective countries to select area of study, because they are the one who knows where they have the data gaps. For example, in Kenya, we got 4 sites from the Kenya Wildlife Service, which includes Mount Elgon, which actually traverses the 2 countries, that is Uganda and Kenya. We had Kora National Park, Savo West and Savo East, which is quite expansive. Actually, it's about 13,700 square kilometers. The main aim for Uganda, we had also 4 sites, which includes Queen Elizabeth, Lake Mburo, which is in the western part of Uganda. We also had Kidepo National Park, which actually traverses between Sudan and north part of Uganda. The main aim of this project was to address the challenges of inadequate capacity in developing these land cover maps and land cover change maps, because not every country, not every government department, directorates and agencies can be able to generate these kind of maps and also land cover change maps in order to come up with decisions. because as you know, GIS comprises of quite a number of components. For example, a hardware. You need to have something like a laptop or a desktop. We also have a component of softwares. Do they really have that software to work on those, maybe to come up with the data? Also, another thing is the user. Do you have the skill to operate these machines? Do you have the skills to interpret images and those kind of things? And also, data is very important. It's part of the component. So the main aim for this project was to come up with a technical user manual, a step-by-step user manual, right from the start of image acquisition, processing, analysis, up to the end you come up to with the product. This study was undertaken under the ICPAC GMES project. These were the facilitators, because as you can see, it's quite a big project which required a lot of resources. Those are some of our products, though I'll mention about them in the next slides. We have a map on showing the land cover, just the general land cover, and the subsequent product is the chart, which shows different kind of land cover within the study area. These were the objectives of our study, the assessment of status of selected national parks and forest. And what we wanted to see from this objective is just the status, what is where, if it's grassland, where is it located, if it's forest, where is it located. Production of land cover and land cover change and related indicators. Also, we wanted to see what are these changes between the initial year, which was 1990, to current year, which was 2019 by then. And the reason why we did up to 2019, we wanted to give chance to these respective governments or respective countries to work on their own using the user manual that we developed. Carrying out future prediction. Future prediction is very important in any study because this gives governments time to plan in order to know where they will put the resources. Also, developing land use training user manual, a step-by-step user manual. This was very critical, and actually it was part of the major objectives. Those pictures were taken in Queen Elizabeth in Uganda, which had a diverse biodiversity with both flora and fauna. Again, in terms of methodology, this study used 10 to 30 meters resolution optical imageries, both from Landsat and Sentinel. And Sentinel, which had at least a temporal resolution of 6 days revisit period and a spatial resolution of 10 meters, while Landsat with a spatial resolution of 30 meters and a temporal resolution of 16 revisit days. The good thing with Landsat, you can be able to go up to 1970s, but with the interest of this project, we just did from 1990 up to 2019. Again, something that was considered when doing this methodology is the seasonality. We went for dry season imageries because you cannot intersect or you cannot compare an image which is of dry season and the one which is of wet season. So it has to be consistent to avoid misclassification, spectral overlap, or spectral confusion. Also, another thing that was very important in our methodology was the cloud cover. We selected imageries with a reasonable cloud cover of less than 10% to avoid also misclassification. Because when you have the shadow and the cloud, you can easily misclassify the image. IPCC, that is the Intergovernmental Panel on Climate Change, was used to map actually the nine classes, which includes open grassland, wooded grassland, open forest, which range from 15% to 45%, dense forest, which range from above 45%, and open water, settlements, and built-up areas. Open softwares was used to generate training samples. This includes the Quantum GIS. It's an open software. You don't need to pay anything, no recurrent fee, no initial fee. It's just free. Then random forest decision tree was used to classify all these classes. After a rigorous suitability test, we realized that these methods were suitable in terms of applying with the software which are free. On the far left, on the far end is we need to appreciate the image. It's Landsat imagery. It's in 4-color composite. And the second map is the land cover that was generated out from that satellite imagery. Then the last product is the land cover change, which was just a subtraction between the initial year and the final year for us to see the statistics. Results and output. Mount Elgon Park was chosen, though we had quite a number of national parks within the 3 countries, but I selected this one for presentation. We could display data in various formats, in table formats, in map form. For example, we have a series of land cover maps ranging from 1990 up to 2019. Also a table showing a same information, whereby you can be able to display also in terms of statistics, graph, trend lines, and so on. We also did the prediction from up to 2050. Prediction is very important because it enables the government or any organization to plan. So from the forest trend line shows a negative gradient. These gradients or these trend lines are very important because it shows an indicator for maybe for conservation and also for rehabilitation purposes. So the forest on this case, which is Mount Elgon National Park, showed a negative gradient, which shows that the forest is reducing. And forest is predicted to reduce by 65% in size by 2050, with a reduction of 1,700 hectares per year. As you can see, the cropland shows a positive gradient or a positive trend, which shows an increase of 246 in area by 2050. With an increase of 3,100 hectares per year. It is showed that increasing size in area of cropland and reduction of forest can be related to increase of human population. This could be as a result of anthropogenic factors or anthropogenic influences. Again, user manual was very important because the main aim for this project was to come up with a user manual whereby a user can click software and get those results that I've just shown you below. We used Google Earth Engine to get some satellite imageries, which includes Landsat imageries and also Sentinel imageries, which are free. This software is very friendly because all you need is to just put up your credentials and log in. You need to come up with the accounts. Also, we used Quantum GIS, which is absolutely free, no initial cost, no recurrent fee used to use this software. All you need is just to download, although you need to check the latest version because they keep upgrading. Another software that was used is the RStudio. This is a free software which provides a graphical user interface for R, and it's for statistical package. It does well with image classification. Expected application, we had data in different formats, such as in charts, in statistics, in map forms that I've just shown you in the previous slides. And from those maps, we could be able to see where are the changes and what is the number, how is it changing. So we tried to analyze this one in a knowledge management platform, whereby in something like a BIPSA, we were able to see or to get the drivers, what are the drivers of this change, and also to come up with the responses. So who are the main collaborators in this stakeholder, in this project? The main collaborators were the GMS Africa, ICPAC, also the government institutions like Kenya Wildlife Service, the Uganda Wildlife Authority, and the DRSRS. Stakeholders were Uganda Wildlife Authority also and the Kenya Wildlife Service and DRSRS. Who are the users? The users were decision makers such as Uganda Wildlife Authority, Kenya Wildlife Service, DRSRS, planning and policy makers, learning institutions such as Makerere University. And actually I have to recognize Makerere University because they helped a lot on this in coming up with this also user manual, critiquing the steps and also giving guidelines. Thank you.
Thank you very much for your presentation. Let me just confirm whether we have these other presenters before we decide whether to take questions or not. Moheli Mohapi, are you present? So we'll skip that. Frederick Mungai? No, and then Stephen Mugo Macharia. Fine, so that means for this session we shall only have 4 presentations. Those who are supposed to be presenters but they're not in. That will give us relatively much more time to interact with the presenters. But we have announcements to make before we call the second presenter. Just a minute. Joachim Opondo from Calro. If you are in this room, kindly go to Biopharma room, first floor in the RCMD complex. And Maximilian Tusime from Uganda. Also, if you are in this plenary, kindly move to first floor RCMD complex in the Biopharma room. Next presenter shall be Alexander Opicho. Please welcome for your presentation.
Dear sponsors who sacrificed for such wonderful program to take place, we say thank you very much. Fellow presenters, colleagues, and friends, I say thank you for coming, and I thank you for being able to be found at such a wonderful place. I'm also seeing younger people, let me call them potential scholars or potential researchers. I send the word of congratulations to you. I want you to be encouraged. Keep on visiting academic, science, and research conferences wherever they take place. This is the way forward. This is the heart of our future, especially the continent of Africa in particular, the global south in general, and the world of humanity in general as well. Our brothers and sisters who don't come from Kenya, we say you are welcomed, feel at home, feel delighted, you are safe, and we are happy as well as we appreciate. We are extremely delighted to have you here. Welcome so much, karibuni sana. Fellow Kenyans who speak Swahili, hamjambo? Mambo? Mukaje? Very good. My name is Alexander Opicho. My work is a lecturer, a researcher, and a writer. My research is focused on ecological democracy. Now, my document is not loading. I don't know what is the coincidence. Do I wait or I proceed? I'm able to present over it.
Okay.
Yes, but
Let's proceed then.
I have some weaknesses, but I will try. Okay. Thank you. The technical department, technical team, I say thank you for the work you are doing there. I think my document had a lot of information and it is shy of opening before the public. So let me use what is in my memory. Later on, when the document will open, you will get the published paper. You will also get the drafts subsequently, if possible. Now, listen carefully. I'm stating the topic or the title of my presentation. It is Analysis of Geospatial Themes. Analysis of geospatial themes in African art, African poetry, and African prose by using a case study of a regional center for mapping and resource development library institution. It is found in Nairobi. It is found within the compound of a regional center for mapping and resource development. If this year you've not gone to any library, I officially welcome you to visit it. It is over at the other side there. So you are highly welcomed. Before I deal with the main issues, I will begin with defining the basic terms which must have come to you for the first time. I will define the word geospatial. Geo means earth. Spatial from the word space means space. So geospatial literatures is a new model of literature, a new model of poetry, a new model of art, a new model of prose, a new model of drama, a new model of polyphonic genius, which deal with stories of environment, stories of climate, stories of the forest, stories of the moon, Jupiter, Mars, black holes, fluctuating levels of the oceans, and any other type of stories that are related to the dynamics of environment and how the Earth relates with other planets in the normal and extra-normal universal system. Why this title? Why this topic right now? Because the traditional literature had been focused on other stories that don't discuss climate as basic capital for human life. If you remember those days you were in school before, the literature you read, thank you. The literature you read must have been about love literature, political literature, science fiction, crime, and others. But our interest now, I know you come from science background, you come from GIS, you come from mathematics, you come from engineering. Now I'm officially bumbling you with a break in monotony to inform you that literature is also concerned with the earth and environment. So what I'm going to talk about is ecological literature, which we also call geospatial literature. So that is the problem. That is the opening observation. This study was influenced and inspired by the work of Professor Sheikh Anta Diop, the late Professor Sheikh Anta Diop from Senegal. He is behind the ideas of Egyptology of humanity, or Egyptian origin of human beings, Egyptology of Africa, of African societies, Egyptian origin of all Africans, Egyptology of the Japanese community, Egyptian origin of the Japanese community, as well as Egyptology of the European communities, or Egyptian origin of the European communities. Sheikh Anta Diop used geospatial approach to develop, to carry out researches in that area of human evolution, abstract nature of the concept of the race, and other theories he used to explain the modern accuracies in relation with evolution as a theory. So the first person to employ geospatial science, geospatial information system, GIS, to explain ecological phenomenon, to explain environmental phenomenon, and to explain human phenomenon like evolution of human species, was Sheikh Anta Diop. He comes from Senegal. He died in the year 1943. Now, since then, scholarship in Africa has kept quiet. In the world of art and cultural studies, you don't come across Africans inspired to use poetry, to use art, to use literature, to use polyphonies. A polyphonic genre is a work of literature which is mixed up with the drama, poetry, and a prose in one text, in one volume. Now, the main problem of this study was to find to which extent has African scholars contributed using poetry, art, and literature to explain geospatial phenomenon. We can move, let's move ahead. Just up a bit, go up definition of terms. I have a few terms to define again before you continue. Because the word library is mentioned somewhere in the document, in my paper, in this paper, a library is defined operationally as a revolutionary space, hosting information or a catchment of information for changing society towards better quality of life. That definition is not mine. It was first established by the Awaz, portrayed Awaz magazine, 2021. The word Awaz is an Indian word. You read W as W, so it's Awaz magazine. Geospatial consciousness, another difficult word to explain. It is human duty and commitment to protect qualitative capacity of the earth and its atmosphere to support human life. You and I, we are endowed with responsibility, both moral and legal as well as human, to protect the earth, to give it capacity to protect each and every life. Animal life, plant life, microorganismic life, as well as any other life that we don't know. Man has a moral duty. Man is the only animal species that can possibly disturb capacity of the earth to protect life because of poverty of geospatial consciousness. Another word, difficult word again to define, is ecological democracy. The word ecological democracy was first used in the year 2021 by Professor Isa Shifchi, Professor Emeritus at the University of Dar es Salaam, when he was holding the Mwalimu Julius Nyerere Lecture of the Year in Senegal, again hosted by the Council of Development in Social Research and Sciences. The most obvious, the most known Codeziria. He argued that ecological democracy is a new form of democracy. People talk about democracies, like in Kenya you talk about democracy. You and I, you think about elections, and maybe rigging or not rigging an election. That is not a serious democracy. That is just but an insignificant issue. It does not matter a lot. What matters is ecological democracy, capacity of humanity to provide opportunity for each and every human being, for each and every other organism with life, to enjoy capacity of the earth to support life. Now, ecological democracy has a two dimension, has vertical dimension and lateral dimension. Vertical dimension is where you are democratic enough to allow the earth to support life in the future. Lateral democracy means you are democratic enough, you are ecologically democratic enough to allow the earth to support life and to support life at your current time. That is what you are concerned with. As a baseline, you need geospatial consciousness or ecological democratic consciousness for you to perfect that. But you can't be geospatially conscious without having information. This information must come in a soft way, packaged in a manner likely to be communicated to any simple person. So the simplest way of communicating geospatial information is community theater, community art, simplest literature, simplest drama, and any other polyphony. The geospatial information published in scientific journals, Journal of Geography, Journal of Earth Engineering, Journal of Meteorology, Journal of Ethnography, cannot be read and be understood by a common person. But a common person is the victim of geospatial dynamics. That is why we need to demystify a geospatial intellectuality into a more consumable model, consumable form, by packaging it a way that it can be consumed by Jack and Jill, any school girl or any school boy that has not gone beyond class 5 or grade 5 of learning. Geospatial literature is the last word to define, is a new model of literature which I encourage you, if you have got your degree in GIS, you've got your master's in earth science, you can do your PhD in geospatial literature. It is now developing at Makerere University. There are very many in South African universities. There are very many in Japan. There are very many in USA and in UK. I hope Kenya will benchmark and change from this literature of love, literature of crime, literature of ethnicity to literature of geospatial consciousness. Okay? Move forward. The objectives of the paper were as follows: to find the extent of geospatial consciousness, as you are saying, to find the extent of drama, as you are saying, to find the extent of prose, as you are saying, to find the extent of other polyphonic genius, as I was saying. But remember, we've not gone anywhere. We are using the Region Center for Mapping and Resource Development Library in Nairobi. It's across over there. When you visit there, you don't go to any other shelf. Go to shelf J and shelf H. I'm not a librarian, I'm a researcher on ecological democracy. Kindly, we can move forward. The conceptual, the theoretical framework, which I won't dwell there for a longer time, is quite simple. It was first guided by Professor, you've heard of Professor Alois Schumpeter. But now the name Alois, you don't pronounce it Alois, it is an Austrian word, you pronounce it Alois Schumpeter. Professor Alois Schumpeter, he is the brainchild behind this argument. He argues that culture influences consciousness, and the consciousness influences culture. So as much as you are doing science research in those complicated laboratories, we saw the drone flying there in the late morning, is it part of our cultural consciousness? Do we see it as part of us? How do we domesticate the drone technology to be part of African culture? How do we domesticate the duty to protect the earth to come from Tokyo summits, COP27 summit is going to come in Egypt in November, other protocols to become part of African culture? I want to confirm to the audience, within our African cultures, we've not sensitized ecological democracy and ecological responsibility. Just without wasting another time, another theoretical support for the study was borrowed from the late Ren Welek. So Welek is spelled W-E-L-L-E-K. It is, again, a German name. You don't read it Welek, it is Welek. So, to the argument of Ren Welek, argues that literature as a space, literature as a socialization is also part of human culture. So human culture is literature, literature is human culture. What you want to achieve, don't just focus on the workshops and the labs alone. Focus on how to communicate it. Focus on how to aggregate that thing to become part of human culture. The way the politicians in the previous era of capitalism and communism used culture to aggregate communist